this ellipse in this kind of weird form here. So when you have when you have it this form right here, you have to put it into this form or this form. And the way to do that would be to complete the square first. So what I'm going to do is group everything that has x's in it. So x squared plus 4x. And then group everything that has y's in it. So if you take this and this right here, and I'm going to factor a 3 out while I'm at it, okay? So that's 3, this is 3y squared. And then if I factor 3 out of that, I get minus 4y, okay, like that. So I'm going to do that. And then the 13, you go to the other side of the equation as a negative 13. Okay, then what I'm going to do is I'm going to add something here and here to make each of these perfect squares. But I have to balance the equation by adding stuff over here. So this one will be 4, because if I divide this by 2, I get 2. If I get 4 divided by 2 is 2. 2 squared is 4. Again, it's also a 4 right there. But really what I'm adding over here is 4. And really what I'm adding here is actually 3 times 4, which is 12. So I got to put a 12 there. Okay. So this becomes x plus 2 squared. And then this is 3 times y minus 2 squared. And this one works out to be 3. Now I need a 1 on this side of the equation, so I divide everything by 3. And I have my 1 there. By default, I have it divided by 1 here. So that means if a is greater than b, that means this one corresponds to the a, and a will be the square root of 3, and b will be 1. And I'm in this case right here. Okay. Now, to graph it, the center is going to be at -2, positive 2. So it's going to be back here, go back 2 and up 2. That's not it. That's not it either. This looks like it could be it, and that looks like it could be it as well. Now, this 1 means going up and down 1 in the y direction, and this looks like more than 1. So from 2, this looks like like 4. So that disqualifies that. And yes, this is 1 in the y direction, and then this right here should be, this distance there is the square root of 3. So that means this is the correct graph, and then not that here. So this would be the one to check mark, and to find the vertices will be these 2 points right here, and this plays off the center being -2, so it's going to be -2 minus the square root of 3, and then -2 plus the square root of 3. The denominator is the square root of 3 quantity squared. Okay, and so that's what you're adding there and there. Okay, so -2 minus the square root of 3, comma, oh wait, the y coordinate is 2. And then -2 plus the square root of 3, comma 2. Those are going to be the vertices. Now, for the foci, okay, for the foci, you use this equation here. And a squared will be 3, and b squared will be 1. So that's 2. So c is √2. And so that means that the foci are going to be right here and here. And the one's going to be -2 minus root 2, comma 2, and -2 plus root 2, comma 2. Okay, any questions about that? Okay, so there's both of them together. Okay, let's move on to the next one, another ellipse. Here we're supposed to just find the equation for the ellipse. So we can start with the center. What are the coordinates for the center? That looks like 2, 2, right? So that means that the numerator will be these. It'll be like that. And for the denominator, what you need to do is figure out these distances here, from here to here, and then from there to there. And this looks like it goes from 2 to 4, so that's 2. And this one goes to, this looks like 7 right there. So from 2 to 7 is 5. So this will be 5 squared, and that will be 2 squared. And that should work. So when you write the equation down, it would be more like this. Okay, so there we go. Just looking at the graph, we can tell what the equation is. Now for the second part, you want to find the foci. And again, you're going to use this right here. C squared is A squared minus B squared. So A squared is 25, and then B squared is 4. In all the cases that we looked at, what's underneath the X term, it has been greater than what's underneath the Y. If it's the other way around, then your foci will be in the Y direction, and this will be your A, and this will be your B. That's 21. So C is plus or minus the square root of 21. So that means that you go from the center in the X direction minus the square root of 21, and then the Y coordinate, and then the center plus the square root of 21 in the X direction, and 2. Okay, any questions about that? Okay, we'll move on to number 7 then. And here we're dealing with hyperbolas. Now, with the hyperbola, things are a little bit different. I like to point a key difference right here. So the A is always on the term that's positive. Even if this B squared is greater than A squared, it doesn't matter. The A squared is always going to be on the, if X squared, if this is the positive term, if it's X squared minus Y squared, then this is going to be your A. If it's Y squared minus X squared, then this will be your A, the one that's underneath the Y. Okay, it doesn't matter. And even if B is larger, it doesn't matter. Whereas with the ellipse, let me go back to the first page. So with the ellipse, it's always the larger value. A is always the larger value. And so you could have this or this. It's just this is larger than that, or in this case, this is larger than that. So these are actually two different cases. Or greater than or equal to. If they're equal, then you're going to have a circle, by the way. And then with the hyperbola, it's always the one that's positive. And then this is how you calculate in any case. So here, another thing is that the focus is always going to be, this c squared is always going to be positive because you have, or 0, because a squared is greater than or equal to b squared. Okay, and they're both positive. Okay, so let's go back to the exercise that we're working on. And I put the equations for the hyperbola right there. So find the vertices and foci of this ellipse right here. So what I'm going to do is divide everything by 144. This gives me x squared over 16 minus y squared over 9 equals 1. Okay, so the vertices, one way that you can get the vertices is by zeroing out this term right here. Okay, so if y is so let me hold on. Vertices. Okay, so y equals 0 crosses this out. Crosses this off. Okay, y equals 0 crosses that off. So gone. And then we're left with x squared over 16 equals 1, which is x squared is 16, or x is plus or minus 4. And so this and this gives you the vertices. Okay. So smaller value would be -4. So -4, 0, and then 4, 0. And then for the foci, again, you use this one. Let me switch colors to green for foci. So for the foci, we're going to use that. And a squared is 16, b squared is 9. So c squared will be 25. That means c is going to be 5. And then you choose the same y value, but plus or minus 5. So -5, 0, and 5, 0. Like that. Those are for the foci. Okay, and then it's a hyperbola, so those are ellipses, and here it goes through the vertices right here and here, and then the foci are at 5 and -5 right here. So the foci are right there. So this is the graph. It's not this one here. Any questions about that?
With finding the asymptotes?
How do you find the asymptotes?
Yeah.
Oh, wow. Yeah, okay. Oh, yes, the asymptotes. Okay, for the asymptotes, what I like to do, let me mark those out here. Okay, let's do the asymptotes. Thank you for reminding me about that. So finding the asymptotes. If you do this, okay, so this is 4, and we've already gone out to these red ones, right, at 4. And this is 3. So if you go from the center up 3, which is maybe about right here, and draw a box. It's actually right here, it actually intersects. So if you have a box right here, then the asymptotes will go through the corners of the box. Okay, they'll go through the corner of the box. So that means that the slope of the asymptote is going to be, okay, it went up 3 from here and across by 4. So that's 3 over 4 is for this asymptote. But you'll have a second asymptote, which I'll do in different color. This one right here. That goes through these 2 corners of the box on through the center. So this went down 3 and over by 4. So negative 3/4. Okay, so you have two asymptotes, and they go through the center, go through 0, 0, so that's not that bad to deal with. So you have y equals 3/4 x, and you have y equals, wait, I may do it in a different color. Negative 3/4 x. So the blue one is this one, and the purple one is this one. Okay, good. And you get it from like using this right here and just like looking at the box. Okay, is that so great. Any other questions about or comments about this one? Okay, so we'll move on to number 8. Identify the type of conic section that this one is. So the type of conic section. So what we need to do is get all the squared stuff on the left, and then you need to divide to make this a 1. So dividing everything by 4 gives you this. And that is, because there's a minus there, then that's and they're both squared, then that's a hyperbola. Now, for the vertices, the x comes first. So setting y equal to 0 crosses this out. And then so those gives you the coordinates for the vertices. So negative 1, 0, and 1, 0. And then again, for the foci, it's c squared is a squared plus b squared. So this is a 1 right here. So that's going to give you 1 plus 4, which is 5. So c is plus or minus the square root of 5. And again, also pairing that with y equals 0. Then that's going to give you the foci when you do that. So negative √5, 0, and √5, 0. Unfortunately, they didn't ask us to graph this. Oh well, too bad. Any questions about this one? Again, I'm right here. I'm just using the equation because we figured out it's a hyperbola. I'm just using the hyperbola equation. Okay, so let's go to number 9. Find the equation for the conic that satisfies the given conditions. Okay, so now here we're supposed to find the equation, and we want it to be a parabola. We want the focus to be at negative 6, 0, and the directrix to be at x equals 2. So what maybe would be a good idea would be to graph this to kind of see where everything's at and see if we can figure out where the vertex would be. The focus is negative 6, 0. So that's going to be out here at negative 6, 0. There's the focus. And the directrix will be x equals 2. So if they come out here to 2, then that will be the directrix. Because it's not part of the parabola, but that's the directrix. Now, for the parabola, the vertex is going to be halfway between the focus and the directrix. So it'll be along the x-axis, and to get the x-coordinate, if we take these two and divide by 2, the average of these two values, negative 6 and 2, then we have negative 2. So here, the vertex is going to be here at negative 2. And we also know that it's going to open to the left. Okay, because there's the directrix, the focus. It's gonna kind of like circle around the wrap, it's gonna like go around the focus like that. So it opens to the left. And also the vertex is what, -2, 0. Yeah, so those are the coordinates of the vertex.
Why is it opening to the left again?
Why do we know it opens to the left?
Yeah.
Because the directrix is right here. Okay, so the parabola consists of all points that are equidistant from the focus and the directrix. So this distance here is equal to that distance. And if you go the other way, then that's not gonna, there's no way that you can get that to happen. Okay, and so even if you come out here further along the parabola, that value, that has got to be that. So it's probably actually probably more like that. Wow. Because that distance has to be equal to that distance for all the points that are, for all points on the, that are on the parabola. That's got to be the case. So that's how we know it opens to the left. It will also kind of wrap around the focus. So those are the clues that we have. And if you go back to the first page, this right here is the pattern for when you have a parabola that opens left or right. Y squared equals 4px. But what you want to do is account for the vertex here. Okay, so because the x coordinate of the vertex is -2, then you change this x to a x plus 2, and then because it opens to the left, then we can put a -4p right here. P is going to be this distance right here, from here to here. So P will be the distance between the vertex and the focus. It will also be this distance here, okay? Between the vertex and the directrix. Okay, and those distances are going to be the same. So that means that P is 4, so you replace this with a 4. So y squared equals -16 times x plus 2. Okay, any other questions about this problem? This is so a lot of the points here, a lot of the things that we have here is makes it so that it suggests that it's a good idea to graph these, because it's kind of hard to see which way it's going to open up, that it actually opens to the left without graphing it. And other stuff too. It should makes it easier to see where you have the vertex and things like that. So let's look at number 10. Find an equation for the conic that satisfies the given condition. So you want an ellipse, And here are the relevant equations for ellipse. We want the foci to be at plus or minus 2, 0, and the vertices at 4, 0, plus or minus 4 and 0. Again, it could be a good idea to graph this. I think I will. So vertices at 4 and negative 4. So if they come out to 4, 0, and negative 4, then those are going to be vertices. And then your foci are here and here. Negative 2, 0, and then 2, 0. Now, as we're going about graphing, finding the equation, then we know that it's going to be, the center is going to be 0, 0, right? So that means the equation will be like this. And since this is a 4, if you take 4 and square that, then that gives you 16. Okay, so 4 squared is 16, which going to make that a 16 right there. Now, the foci, this distance here is 2. So c is 2, which means that c squared is 4. So now to find this guy right here, then we use this equation here. So c squared is a squared minus b squared. This is b squared. B squared is going to go there. And we know that c squared is 4, and a squared is 16. So bring the b squared over here. Subtract 4, you get 12. So that's going to be 12. And so this is going to be our equation right here. X squared over 16 plus y squared over 12 equals 1. Any questions about that one? Okay, let's move on to number 11. So here again we have an ellipse, and this time we want, it only gives you S1 of the vertices, but here are the foci. So let's go ahead and graph it and put the foci on. So 0, negative 2, that's going to be down here. And then 6, negative 2, so that's going to be up here at 6. Wait. No. No, no, no. 6, negative 2 is over here. Okay, so those are going to be the foci. Vertex is going to be 7, negative 2. That's probably not very well drawn because that's just negative 2 right there. Get that closer. Okay, so that's more like 7 right there. Although, oh well, not going to worry too much about this. About the details. So that means that you'll have another vertex down here at negative 1, because this distance is 1 between this vertex and that focus, then the distance between these two is also going to be 1. So this is going to put another vertex here at negative 1. Although that's not that important, the center of the center is going to be the average of these two, the two foci. Okay, so 0 plus 6 over 2 gives you 3. So the center will be here at 3. Or 3 comma negative 2. Okay, so because of that, that means that our equation is going to be like this. x minus 3 squared plus y plus 2 squared. We're going to be over things. This distance from 3 to 7 is 4, so that will be 16. So that goes there. This distance is also 4. Same thing. So that's going to be 16. And then for the last piece right here, we use this because we want to find the b squared. And we know c squared. Okay, so c squared comes from this distance here, which is 3. Okay. So c squared is 9. So that's 9. And then a squared is 16. So b squared is 7. So we'll put a 7 in there, and that should do it right there. That should do it. Any questions about that one? Okay, let's do number 12. Is that the last one? Yeah, number 12 is the last one. So one more to go. Find an equation for the conic section that satisfies the given conditions. So you want a hyperbola, vertices at 0 plus or minus 3, and foci at 0 plus or minus 5. So 0 plus or minus 3. So if we go up by 3 and down by 3, those are going to be our vertices, which means the center is going to be at 0, which means that we can just put it in straight like that. Okay, so the vertices are these, and the foci are at 5 and negative 5. So this is 5, and here's negative 5. 0, negative 5, and 0, 5. And because it's oriented horizontally and it has to go through this point, y has to be able to be 3 when x is 0. Okay, so these points are on the graph. So for example, 0, 3 is on the graph. It has to satisfy the equation. If you try to put it into here, if you try to do this, there's no way you can get this to work. Okay, so in other words, if you try to put a 0 in for x, that's not going to work. It can't work because this is negative. Because if you zero that out, then you have negative 9 over b squared equals 1. You can't. That has no solution. So that means you have to go with this one right here. Okay, so this is going to be. So this means right here. This means that this just, or I should rather say this right here. This distance is 3 from the center to here, and also 3 from the center to here to this vertex. Okay, and then this tells you that, and then 3 squared is 9, which goes right here. And since it's in the vertical direction, it's under the y. Okay, and then we have x squared over something equals 1. And this something comes from here again. So C comes from this right here. This distance is 5. So C squared is 25. This becomes 25. And then A squared is 9. Plus B squared. So B squared will be 16. And that goes right there. Okay, so that's going to be the equation. Now, if you want to find the other things, okay, so that at that point, if you wanted to graph this, we would come out here to the square root of that, which is 4, and -4. Wait, that's a bad place. So 4 and -4. Draw this box right here. Draw the asymptotes, which would go through the corners of the box. So this will be y equals, what is this? It goes up 3 and across by 4, so 3/4 x would be this asymptote. This other asymptote is when if you start from the origin, it goes down 3 and over 4, so -3/4 x. And then the graph will start here and go out towards the asymptote, like that. Kind of curving around so the focus, this focus is inside the curvature of this part. This focus is inside the curvature of this part. Okay, so any questions on that right there?